This is Chapter 21, Example 2. This example problem is similar to the previous example problem in that we are storing previous values, but in this problem we are both storing them and comparing them. So this problem is a little bit different also in that I only have to store two previous values and compare that to the current value. So the current value isn't something that needs to be stored. I only need to store the two previous values. So the first step in this problem is to draw the interface. And there it is. Now problems like this have startup issues that we're not going to deal with, as in when you power the circuit up, what is it going to do for the first two clock cycles? And we're not going to worry about that for this problem. So we agreed that this problem needs to store two previous values, and so we need two flip-flops. There are our flip-flops. Next step in this problem is to say we need to hook this up such that it stores the values correctly. Right now it's not storing anything, so what we're going to do is store that first value and store the value that's already been stored. Now at this point what we want is this signal here, this signal, and this signal to indicate when they're all the same, we want the output EQ to be turned on. So what we're going to do here is choose our equivalence gate, which is XNOR. When those two signals are the same, this will indicate that with a 1 on the output, and then we need to compare one of these signals with the current signal, and so that's another XNOR. So when both of these XNORs are equivalent, that's when the EQ turns on, and so what we need to do is toss in an AND gate there. At that point we call this problem done. This problem has no control inputs on the various circuits in there, so this is a classic no control problem.